Hello everyone and welcome to our next lecture. In the last lecture we dealt with the basics of computers and its different devices. Okay, so now we will deal with the history of 8085 microprocessor. That means from where actually this microprocessor came into existence. Okay, so let's start with 8085 history. See, in 1971 Intel company has made a microprocessor and given the name 4004, and it was an 8-bit microprocessor. So most probably this name 4004 is given because this is of 4-bit microprocessor. This may be most probably. Okay, then in 1972 Intel has made a one more microprocessor which is of 8-bit, and they named it as 8008, that is 8008. Okay, then in 1973 again a new microprocessor with the name 8080 came into the existence. This is also of 8-bit microprocessor, but definitely it had some advanced technologies compared to 8008. Similarly, then Motorola came, Zilog. That means after 1974 there are some more companies which came into the existence to form the new microprocessors. Okay, they all are of 8-bit microprocessors, and in 1976 8085 came into existence. So before going to 8085, and let's see how these microprocessor are getting evolved, evolutions of microprocessor. Okay, so we will do the evolution of microprocessor. That means how these microprocessor came into existence one by one. As in the last lecture we said that the first microprocessor that came into existence was 4004. I told you right now, and it came into the existence in 1971-72. Okay, 4004. I told you right now. I will show you the slide once again. Just check. See, 4004 in 1971. It was a 4-bit microprocessor. So actually, the working of first generation microprocessor is that they first fetch the instruction, they decode the instruction, and then they execute it. That means they process on it. Okay, this is the actual working of any microprocessor which came into the existence. So the first generation microprocessor actually have this thing. So you also keep into mind your thing that any microprocessor actually works in this way only. They first fetch, then they decode, and then they execute. Okay, so this is the way of the processing. Okay, now when once they do this on one instruction, then they start the same processing with the another instruction. That means once the first instruction's execution is finished, again they fetch the first instruction, they decode it, and then they execute on the first instruction. Okay, this is all about the first generation microprocessor. Okay, that means what happens, the pointer is fetched the following instruction performing consecutive operations. That means this operation came just it repeat itself after every instruction is executed. Again they fetch the another instruction. So this keep on doing till your program does not ends. Okay, then comes second generation microprocessor. So second generation microprocessor is normally of 16-bit, as you can see from here. That see, they are 16-bit arithmetic 7 pipeline instruction processing. Now pipeline instruction processing means where the process of fetch, decode, and execute work simultaneously. Simultaneously means if first instruction is fetched, then when the first instruction is decoding itself, the second instruction will be fetched. Okay, so this is called actually the pipelining instruction. Now these examples of second generation microprocessors are MC68000, which is made by the Motorola company, so it is called Motorola microprocessor. And then Intel 8080, you can say that Intel 8080 is also the example of second generation microprocessor only, along with MC68000. Okay, so now the word overlapping, as it is written that it is overlap, means the same thing. When you are actually decoding the first instruction, you are fetching the second one, so it gets overlapping. Okay, there is some kind of overlapping. Now the most important thing is the difference between the first generation and second generation microprocessors. In second generation microprocessor, as compared to first generation, we are using new semiconductor technologies. Okay, that means to manufacture these chips of microprocessors, we are using the new semiconductor technologies. Maybe the number of transistors are increasing, or they are actually using the transistors to make this particular kind of microprocessor. So it started in second generation. Okay, now the advantage of using this semiconductor technology is that they have increased the instruction speed and execution speed also. Okay, this is the most important advantage. They have higher chip densities too. So these are some of the important, or you can say the advantages of second generation microprocessor. Now comes to third generation microprocessor. A third generation microprocessor was actually came into existence in 1978, as you can see. And in 1978, Intel 8086 came into existence along with Zilog Z8000. Okay, so there are two different kinds of microprocessor came into the market, and they are actually 16-bit processor. So instead of using 8-bit, now they can deal with the 16-bit. That means what? The more the number of bits will increase, the more speed will increase. Okay, and they will take less time to execute. That is the most important part of third generation. Remember this thing. Now what happens? They actually started performing like a mini computer. This is the main thing of a third generation microprocessor. So always remember that in this, what happens? The workstations, industries begin evolving their own ISC based microphones architectures. That means now, till the third generation came into the existence, every company, every industrialist has started their own ISC based microprocessor. They have started the architecture of those microprocessors. Okay, so there are many companies which came into the existence till the third generation microprocessor. Then comes fourth generation microprocessor. Now what happened in fourth generation microprocessor? See, it till third generation, normally the microprocessor are used for commercial purpose, but now they have started some house designings. That means not only for commercial purpose, but also for our some regular works or some kind of light works, we can say. Okay, so this is the most important thing, that many industries have converted from commercial microprocessors into an in-house designs. Okay, so the fourth generation completely depends on this thing. And more important thing is that they have actually made a design with millions transistors. So remember this thing, there are millions of transistors used in such a small chip. The examples are Motorola 88100, Intel's 80960CA. Okay, these are some which actually, these are some microprocessors which actually work on, you can say per clock cycle, they can work more than one instructions. As I told you earlier, that what a microprocessor do, the first generation microprocessor, they in one clock cycle, they first fetch. Okay, maybe in the other clock cycle they decode it, then in the other they execute it. Okay, this is how a microprocessor started working. But now till the fourth generation came, in just one per clock cycle they can work on more than one instruction. That means the speed has increased, the time taking to execute it has reduced to much lesser time. Okay, then the last and fifth generation of microprocessor, this is the very, you can say, completely new technology is used. That means in the fifth generation microprocessors, the company has actually employed a decoupled superscalar processing. Okay, and their designs are like they have exceeded up to 10 million transistor. That means, can you imagine, just single chip, we are using more than 10 millions transistors. Okay, so this is the main, you can say, the feature of fifth generation microprocessor, the most important. Okay, they are actually of low margins, they have high volume businesses, है ना? So one, everything is going on in just one single microprocessor. Remember this thing. So let's see, you can check from here the history of microprocessor. That means, first of all, what happened in 1947, a transistor was invented. Okay, remember, that was invented by Bell Laboratories. Okay, then an IC which is called integrated circuit, that was invented in 1958 by J. Kilby, who belongs to Texas Instruments. Okay, and after that Intel has invented its first microprocessor, the same 4004, okay, in 1971. So from 47 to 58 to 71, this is how, and till now the microprocessors, they are actually improving day by day, we can say. Okay, this is all about your microprocessor, its history, its evolution, you can say. And since Intel is the first company, so just see from where this name Intel came. It is actually a company with the name Integrated Electronics. Okay, so that's why this Integrated Electronics, they short make it a short form of Intel. This is how a company named itself. Okay, now let's see overall evolution in just one single data. See, in 1974 they have started, which why they have started from 1974, as I told you that in 1971 first microprocessor, that is 4004, came into the existence. But as I told you that in second generation they have started using the transistors. That's why 1971 is not included here, because they are using those microprocessors which have actually used the number of transistors. So starting from thick 6000 in 1974, 8080 was the first microprocessor which is of 8-bit microprocessor, you can say. Zeta width is of 8-bit. It has used 6000 transistors. Its clock frequency is 2 megahertz. That means this is the way how it works. The speed is 2 megahertz clock. And as day by day the microprocessors are improving, nowadays we can check from here. See, the number of transistors are also increasing from 6000 to 6500, 29,000, then 1,34,000, which you can say 134,000 also, 2,75,000, and then you can say 12 lakh or 1 million transistors. Okay, 1 million 20 lakhs, sorry, 1,200,000 transistors. So this is how the number of transistors are increasing, and as the number of transistors are increasing, its speed is also increasing, and the time is reducing. That means the processing time is reduced to a very 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 much time. See, Pentium 4 has came in 2000, in the year 2000, and you know there are many more microprocessors nowadays working. Number of transistors, as I can check from here, you can see the same. This particular slide has been shown in this chart. You can see the graph. See from here, as I told you, in 1982, 80286, 80386, and they have more than, how much, more than 1 lakh transistors. As you can see, I will show you in the next yes. Now see, in 1982 they have started more than 1 lakh. Okay, 80286, and yes, 80286, 80386, and 80486, they are the you can say the extended version of 8086 only. So they are of 16-bit, and then the extended version means 32 bits. 386 and 486 have used the 32 bits data bits. Okay, and then the number of transistors also increased in 486 and in 386 compared to 8086, which have used only 29,000 transistors. So you can see from here also, 1971, 4004, number of transistors very less. Then came 1974, 8008, which actually shows from here. You can see 6000, somewhere around 6000 transistors. 8082 mein 286 and 386 has increased up to 1 lakh. Okay, and it is increasing even till today. So you can see the more the number of transistors in such a small chip. Okay, so this is all about the evolution of microprocessor. From the next lecture, we'll begin with the 8085 microprocessor, its basics, its architecture, pin diagram, and other things. Okay, till then, take care. Bye bye.